Hi, my name is Aleks Seovíc. I'm one of the architects on the Coherence engineering team. And I'm here with my colleague from the Helidon team, Dmitry Aleksandrov, to talk to you about how to build scalable microservices and applications with Coherence and Helidon. So Dmitry, why don't you kick us off and tell us how you can build Helidon applications?
Hello. So it's a great pleasure to be here in this session together with you. So yes, I am one of the software developers working on the Helidon team. And yes, actually, I'm going to drive you through the first part of this presentation on the Helidon part, actually. So just to show you the slide that everything changes so fast. So before making your business decisions, like to review everything. And I think with this, we're ready to go. So Project Helidon, that comes from our name session. What is a Project Helidon? So we call ourselves as a set of libraries, Java libraries for developing microservices. And whatever you need a microservice, Helidon.io is actually one of your first choices, I believe. So just join the website and you will find all the required information and how you can write microservices. So you probably wonder what Helidon means. Actually, it means in Greek, swallow. It's a small bird, it's like flying very fast and flying in flocks. And whenever you see it flying, it kind of reminds us the world of microservices. So I believe the name of Helidon, the swallow itself, was chosen really in a great way. So one of the best parts of Helidon, actually, that is totally open source. So whenever you need to see how it works from inside, you just go to github.com/oracle/Helidon, and you see all the information, all the code, everything you need, all the issues, it's absolutely free and under Apache 2.0 license. It is built on top of Netty, so we are very asynchronous. We're synchronous by our thoughts. And what we do, we try to do it in a very, very, powerful way. So Netty is a good, powerful foundation for us. And as a result, we are absolutely cloud native ready. What that means that it not only get a REST endpoints for your microservices, out of the box, you get health, metrics, tracing, everything you need to do and to run in the clouds. And of course, we should be small, like everything, like micro should be really micro. And to make it even more micro, we are now fully supporting GraalVM native image for almost all of our code, which makes us really, really competitive on the market. So, and nevertheless, we are absolutely Java 11 plus. What that means that no compromises at all. We are using everything which is completely new and everything which is like brand functionally new in Java. And we use it in the very best way. So no compromises, only the best for you. So at a high level, our Helidon looks like this. So actually we have Netty as a foundation. Then, as we said, we are very, very asynchronous and reactive. So we have this layer of Helidon reactive or Helidon as foundation for the next level, Helidon MicroProfile. So as I said, MicroProfile, actually this will be the focus of our presentation. So as we said, we are like a set of libraries, but we are kind of positioning ourselves as a microprofile based framework. That means that everything you need for creating your applications, you can do it in a standard microprofile way. As I said, standard, actually that standard means. So probably most of you have heard about microprofile. Just to remind you that this is an open source community specification for enterprise Java microservices, which is what? It's not an implementation. It's really a set of specifications that many vendors implement. So our team as well. So currently it's hosted under the Eclipse Foundation, and there are lots of participants. It's not only Oracle, it's IBM, Red Hat, Archetype, and even Microsoft is there. And with a high cadence of 4 releases per year, this specification evolves really quick. currently, to support your microservices, there are 12 main frameworks, actually not framework specifications, listed here. So although actually MicroProfile started only from 3 specifications, now that they at version 4.0, they're 12. And as you see, they're all in different versions, so they evolve in different speed. And this makes it really nice because it really fits the best standards of the demand of the market. So where is actually Helidon here? 4.0 was released really like not several days, but several weeks ago. So to implement everything, we need some time. And now we are at version 3.3. And as you see, we are supporting many frameworks, many specifications from MicroProfile, as you see, like config, fault tolerance, metrics, etc. We also do support specifications from Jakarta, which is like CDI, annotations, persistence, etc. And even more, we support, as we say, additional specifications which are not exactly part of the release of MicroProfile. One of them is GraphQL, and even more of that, we support what's highly demanded specifications like CORS and gRPC. And as you see, when you download Helidon, you get all of these specifications directly available to you. And this was like the microservice part, and I will give it to Alexander, which will actually tell us about how to persist state there and why coherence is the best choice for that. Alexander, it's your turn.
Thank you, Dmitry. So as you can see on the slide, Geir Magnusson Jr. at one point many years ago commented at one of the conferences that coherence is the world's most expensive hash map. And it's funny because it was kind of true at the time, but it's not true anymore. For one, it's a lot more than a hash map now. It's not just a distributed cache anymore. And 2, it has been free since June of last year when we released Coherence Community Edition. Next slide, please. So Coherence was created almost 20 years ago, or actually about 20 years ago. In 2001 was the first release of Coherence, but it's still surprisingly modern product and very well suited for modern cloud applications. It is really just a library that you can embed into any Java application. You can run it as a server, but in many cases you can just, as you'll see today, you can just embed it as a library into an application using whatever framework you want to use, Helidon, hopefully, and just run it as part of your application. It's easy to deploy to Kubernetes using Coherence operator. It's easy to manage. You can monitor it using Grafana and Jaeger and Prometheus, etc. So go to the next slide, please. So when I said it's not just an enterprise hash map anymore, what I mean is that over the years, Coherence has become a powerful, scalable, fast, general purpose key value data store. We added persistence back in 2015, which made it durable as well. And the way Coherence works makes it really well suited for the cloud environments and for the cloud applications. We partition data across many processes, many servers, many cluster members in order to scale both the capacity and throughput of the cluster. And we create backups as far as possible from the primary data. So if you lose the whole data center, Coherence should still be up and running and have all your data available for the applications. We also support many modern features such as parallel queries, aggregations, and in-place processing to make it more efficient to do things in a distributed environment. Next slide, please. We are also an event streaming platform. The latest release of Coherence introduces named topic, which is probably second top level data structure in addition to name map that we've had from the very beginning. So named topics allow you to do pub sub messaging, kind of similar to the way Kafka does it. And you have subscriber groups, subscribe to messages, publish messages, and they're durable, persisted to disk, etc. And we've also had events, and that's one of the things we'll be showing in a demo today, the usage of Coherence events to propagate changes from the server to the client. And we can also have events that capture things on the server as well. So Coherence is very well suited for event-driven event streaming applications. Next slide, please. And yes, we are still a cache, and a pretty good one at that. I mean, Coherence supports all the possible caching topologies you can think of. You can use it as a cache, but as I said earlier, it's not one of the most important or primary use cases anymore. Next slide, please. So it's time to get into the demo and look at some code and look how it runs and how we can scale it out. Next slide. The application we'll be building is a simple task management application, a to-do list app. And it's fairly trivial, but it's good example to demonstrate some of the features, both at the API level and also at the operational level. So we have a React front end that is actually served by Helidon as part of the application. It's embedded into the application. So, and we also have Coherence embedded into the application. So if you think about it, you have front end, back end, Coherence persistence layer, and Helidon, which provides your application layer, all together, all bundled together in a single process. We can build single Docker container that has all three of them in, start many of those containers up, as we'll do, and we'll be able to connect application and use it. So with that, Dmitry, why don't you kick us off?
Yes, absolutely. So we should start coding. So how can we actually start coding? So first of all, Helidon will mostly use Maven to build everything. So you just have to use an archetype to start your project, which is like this. And then you only have to add like dependencies in your project, like MICROPROFILE, since this is the way we're going to do this today. And we are almost set up. There's a different way of doing it. Let us say like more guided interface, or how is it, graphic interface user friendly, which is like to go to the MICROPROFILE and use the starter page and just select Helidon as your runtime, and you are done. And it will generate you actually the POM file, which you can use in your project. But especially if you have prepared a more advanced, modern way of doing things, this is our CLI. So you can just download it from our official website and start using it. So let's try it actually. So here I got my command line. So we will now create an application. So we need only to type in Helidon in it and like answer a few questions. So first of all, the flavor, as I told you, we have a reactive API is available to us, our MicroProfile. So we choose the MicroProfile way of doing things. So just type 2, and we will create really minimalistic application, which is able to run. And we will call application to the list. Group ID will be like io.helidon.coherence.todo. Artifact name will be like to-do list. Of course, version 1.0 snapshot, and our default package will be like io.helidon.coherence and .todo. And this is probably almost it. So especially for you, there is a so-called start development loop. So whenever you do changes, it will reload the project and build it for you. But at this point, we actually don't need it. So if we take a look at our directory, it will create an application for us. And yes, we just take a look what actually there is in this application. Well, there's quite a regular structure. So it has a source folder with some Helidon classes and resources for us and tests for us. So, and a POM file, of course, to run everything. So it generates you a typical Maven project, which will be running. Just to save you time, we got this project, and we have already prepared some of the classes we're going to use to create our first microservice, actually. So once again, Helidon is used to build microservices. So we will create our first object, which will be the task object. We're going to walk through the code. So it only has a created that, completed field like Spring, which will be task ID and the description. Of course, we will need a constructor. We will get the getters and setters methods. Of course, we will need the equals and hash code methods to make everything correct. And of course, the string. Next thing we're going to do, we'll create an abstract service, which is like our to-do list service. It has several methods. Currently, they are null. They're returning nothing, but they will be done in future during today's session. So we will actually create a task. So we'll create a task. We'll get a collection of tasks. So probably all of them, which are completed or not. We will search for a task, to search for a task, and like, delete completed task, update description. So CRUD operations over them. Lovely. So this is our job part. The next thing we're going to do is actually expose this service via REST endpoints. So since we are MicroProfile, everything is done with MicroProfile annotation. So this code is very, very standard. That means that everything you do, it's actually portable. You can put it to other service, or maybe you have code which is already written for some other runtimes. You can just plug it in and it will work out of the box. So what we will do, we'll create a path, say that our API will be available under this URI. We will inject our to the service. And then there are some, typical getters and get posts and delete methods, which will expose like our CRUD operations via REST endpoint. The annotations themselves are absolutely standard. So we will have like create events, create task, delete task, delete completed task, and update task. This is enough for us for to make our service like proactive. We'll also use so-called server-side events, which will broadcast our events out of the service. So just to let you know that we have our POM file and actually what you do. So we just add those SAC down to our POM files. So the REST service itself is very straightforward, but Helidon is not only about REST. So we also can expose data in a different way, or service in a more advanced way, let us say. So highly demanded now is the GraphQL way of exposing the services. So I'll create another class, which will just expose our to-do list graph API with just one annotation, which will be like GraphQL API, and that's it. So you probably see all the same, kind of the same, I would say, methods like create task, get task, find task, but with a different set of annotations. So in our case, to get a task, we will get a query with some description and some parameter. If we change something in terms of gRPC, it will be mutation. So we'll annotate it as mutation. And last but not least is the third way of exposing our service, which is the gRPC way of doing it. Once again, we are just a class which we just inject our API. We annotate this class with gRPC, and almost the same way we are creating annotations, and all these methods, we annotate them with specific to gRPC annotations. So if there is a unary operation, we create task, we just annotate it unary. If there's a stream of events happening, we just create service streaming. And yes, in this way, we are exposing with Helidon, as you probably saw. Actually, once again, let's get to the POM. So for all this way of exposing, you just add a dependency like GraphQL server, like gRPC server, and it will work and build out of the box. So Helidon, as I said, is your way to expose microservices. And now I believe it's a good way to, it's now completely stateless. Now with coherence, we will just add some state. So I will hand my screen to Aleks back. Aleks.
Thank you. You share my screen. So I'll take over where Dmitry left, and we'll enhance these classes a little bit to make them suitable for coherence. First thing that we're going to do is add these annotations to our task class. So we'll add portable type to the class itself, and we'll add that portable to the fields. This will make this class serializable in a format Coherence understands, in a portable object format. We could have done just a simple implements Java serializable, but POF is way more efficient and more suitable when you're working with multiple platforms, if you have clients in other languages like C++ and .NET. So we'll enable POF. So that's all we need to do in our class. We have Maven plugin configured that will actually take those annotations and implement serialization code for you. So we have POF Maven plugin that will actually do the serialization for you. So the next thing is we want to implement repository for our task objects. And repository is really a pattern that everybody's familiar with. It's something that Martin Fowler has written about, and something that Eric Evans has written about in domain-driven design as well. So we want to basically look at the coherence as a repository of tasks, or a coherence named map as a repository of tasks. So we can extend abstract repository class that comes in coherence in the latest 2106 milestone release. And we can simply implement a few methods. We can inject named map, which is the actual coherence named map that we are going to be storing tasks in, and implement a few methods that abstract repository requires to implement, which is to give it the map that we are storing tasks in, how to get the ID from the task entity itself, and what the entity type is. And then last but not least, we actually decided to add a custom finder method to our repository implementation. So we have a finder method that allows us to find tasks by completion status. And that uses coherence filter API. So we can, if completed parameter is null, we want to get all the tasks. So we're going to use always filter. If it's not null, then we want to get all the tasks where get completed attribute returns either true or false, whatever the completed value passed in is. And then we delegate to the find all method on the abstract repository, which will basically execute that. And as a second argument, we specify the order, which is the creation order of these tasks that we want to return the results in. So that's an example of a finder method. And then if we look at the service itself, we see that it's just another CDI bean. We inject task repository we just created, and then we simply delegate to it for most of the methods. Most of the operations are really one-liners, right? We can call task repository save with the new task to create the task. We can call the method we just looked at, find by completion status, to get completed status, et cetera, et cetera. Now we can also modify, right? In the case, tasks find by ID, which we call in the repository, will either return null or the task that we have. But in this case, our contract for the service says that if the task is not found, we should throw not found exception, which plays nice with REST and GraphQL and gRPC. So we're basically just wrapping this of optional of nullable, and if it's null, then we are throwing not found exception. Same thing for delete task. And then delete completed task is again one-liner. We're just saying tasks repository, remove all tasks where get completed attribute is true. Finally, we have update description and update status methods. And these are interesting because they're really what makes coherence different from many other data stores. In most cases, you would be expected, when you want to do a mutation on an object, on an entity, you would typically read that entity from the data store, modify it within the application, and then write the updated entity back. Coherence allows you to actually do mutations in a much more efficient way. So instead of moving the data over the wire to the client, changing it and moving it back, you can actually just send a function that you want to execute and execute it where the object lives. So we have tasks somewhere in the cluster. We don't really know where it is. We don't really care where it is, but we want to update it. So we can update task with this given ID by calling this method on it and passing it this argument. So that's one of the examples. You can actually do it in a more flexible ways. I mean, you can actually pass functions and by functions and whatnot. So, in this case, I guess this is by function because it actually returns a task. But that's really one of the powerful features that coherence allows you to use to update objects in place, which is much more concurrent and much more efficient than if you're doing it the conventional way. So finally, let's look at some additional wiring. We want our clients to be updated whenever something in the backend data store changes, whenever something in Coherence changes. So we'll add a little bit of code to the REST API that Dmitry showed earlier. So we'll inject our task repository into our REST API, and we'll register a listener with the tasks repository, so we can actually propagate coherence events that this listener is receiving to the SSE broadcaster, to the client, to the direct client. So we'll basically take a listener, and whenever task is inserted into coherence, we'll broadcast it to all the registered clients. Updated, we'll broadcast it as an update event. Removed, we'll broadcast it as a delete event. So that's the event wiring for that. And then we do something similar in our gRPC API. So we'll for our events method, which is server streaming method, we'll add listener that basically calls observer on ask with the task inserted object, task updated object, or task removed object. So it's slightly different model with gRPC versus REST, but we can easily accomplish both of those goals using coherence events. So another thing to point out about Helidon gRPC in general and what we do here is you notice that we don't have any proto files. We don't do, and we don't actually use proto buffers because we are using POF for gRPC as well. We configure gRPC marshaller as POF. We configured service, what we want its name to be. And then by injecting these methods and marking them with unary or server streaming, etc., we're basically creating our service. And then on the client, we can simply create an interface that has methods that the client needs, doesn't have to have all of them, and we can invoke them. Helidon will generate proxy for it automatically. So with that out of the way, that's pretty much the whole code walkthrough. Let's look at how this actually works. So what we have here is a list of tasks. I already started this in my local Kubernetes cluster, and I can add some new tasks. And you can see that as I type this, my React API that I typed into was updated. My JavaFX API that uses gRPC was updated. If I mark things as completed in one API, they show up as completed in the other. I have my GraphQL API at the bottom, so I can query for tasks. Right now, they're marking as completed. I can also create tasks from GraphQL by using mutation, and it will show up in both of these APIs. We can complete additional tasks, and then let's say from GraphQL, we can delete completed tasks, which will remove them from everywhere. So that's pretty much how the application works. We rely on the events to update any client, regardless of which facade to the API it's coming through. So, JavaFX client is coming via gRPC API, React client is going over REST API, and then we have GraphQL, which is GraphQL client, which uses GraphQL API. So they're all updating the same data store and they're all receiving events. Well, GraphQL, we don't have support for events yet because it's supported in a GraphQL spec, but it's not supported with MICROPROFILE GraphQL spec yet. So once we have that, we will have support for events in GraphQL as well. So how does all of this work? So I have a cluster running that has 6 pods right now. So 0, 1, 2, 3, 4, 5. If I look at what my coherence resources are here, I can see that I have cluster to do with 6 replicas and 6 already. And at the very beginning of the presentation, we said that this is about building scalable applications. So what do we mean by that? Well, we mean that this is now a stateful application. We are storing data. And just so you can see that as well, we are storing data. Each of these pods has a persistence volume claim attached to it. So each one of them has a disk that the data is ultimately written to. I can shut down the whole cluster and bring it back up, and the data will still be there. So how easy is this to scale? Typically, stateful workloads are fairly difficult to scale, but in this case, it's as simple as scaling a stateless workload. So we can scale coherence to do replicas 10, and it's scaled. Not really scaled, but it's scaling, right? So we have 6 replicas. If we look at the pods, you will see that 3 new pods are being added, or actually 4. Yeah, so 4 new pods are being added, and we're going to have 10 pods in the end. If you look at the PVCs, you will see that 4 more PVCs have been provisioned. So, and that's all good, but we only scaled to 10 nodes, which is all I have room for in my homegrown cluster of Mac Minis. But I have a real cluster running in OCI, and there we actually have a lot more pods. So I scaled the cluster before the session to 700 nodes. So you can see that we have to-do list all the way to 699, from 0 to 699. And if I look at a cluster, I can see that I have 700 nodes ready. So how hard is this to scale? Well, it's just as simple as what you already saw. So let's scale it. Well, let's scale it to 800. And it will take a few minutes, but in the end, once everything is started, you will see that we have 800 nodes in a cluster. And just to see how that looks like from a monitoring perspective, we have our Grafana dashboards, which right now only shows 700 members because we're still in the process of starting additional 100. But you can see that we have 700 members running in a cluster. We have 1.5 terabyte of space allocated that you can use to store data. And again, each one of these 700 nodes is also used by, to accept HTTP, gRPC, GraphQL requests via Helidon endpoints, and delegates data operations to Coherence, which then persisted to disk in the cloud using provisioned volume planes. So that's pretty much all we had for the demo. And Dmitry, if you want to say a little bit more about Helidon and where people can find some additional resources, go ahead.
Oh, yes, absolutely. So as I said, the main resource is helidon.io, which you can find everything, which beautiful documentation that we have to start coding right now. So then we find the CLI as I demonstrated to you. We have some long reads, big articles about usage of specific components at our Medium page. Once again, all the code is available on GitHub. So it's Apache 2.0 license, which is like awesome. And you not only can see the code, but also contribute. So we have a lot of new contributors, which is beautiful. Whoever doesn't like to read a lot, I would say, we have prepared our YouTube channel when we regularly show new videos demonstrating features of Helidon, like each of them, as I said, what is REST, what is gRPC, what is GraphQL, etc., etc. And of course, if you have questions, you want to ask them live, go to our Helidon Slack channel. So be welcome.
Dmitry, and similarly for Coherence, you can have main Coherence community site at coherence.community. We have Medium, which doesn't have nearly as much content as Helidon because we just started building it late last year. But there are some really useful articles if you're just getting started with Coherence, including the article that kind of walks you through the whole process of building the to-do demo in much more detail, to-do demo that we just showed. You can find Coherence source code for the community edition on GitHub at github.com/oracle/coherence. There are a number of YouTube videos on our YouTube channel, both for the old releases that show many features as they've been developed over the years and for the new functionality. And then finally, as Dmitry said, if you have any questions or need help or just want to provide some feedback, our Slack channel is at oraclecoherence.slack.com. So with that, we can move on to Q&A. So the question is, you said that Coherence optionally persists to disk. So why is persistence optional? Well, because again, historically, if you look at Coherence, Coherence started as a caching product. It was the first distributed cache that people could use to synchronize state between different processes, typically Java EE application containers. Over the years, however, as customers asked for more and more functionality, we realized that, well, actually it was driven by, even persistence was driven by customers, because customer kept asking for us to make things, not expiring. And, they just wanted to use Coherence as a system of record more and more. And at some point they asked for durability. So we added persistence as an option. You can make your caches persistent and durable, but it's not required. It's not something that you have to use by default, because there are still plenty of use cases where you don't need persistence. You don't need the overhead of both performance or the size of data on disk. You just want to have some data cached in memory, and that's why persistence is optional. But if you want it, it's there.
Oh yes, Helidon. So the question is, can I use Helidon to write something other than microservices? Actually, I think it's a bad idea. So you won't write any graphical user interfaces, or you can't write any like, well, I don't even can't imagine what can write. But if you want to make microservices exactly in the way actually microservices should be, rather small, fast, scalable, resilient, and following this pattern, Helidon is definitely your choice, since once again you provide two flavors of it. So first one is this MICROPROFILE, which is the standard way of doing things, which is not even standardized way of doing things. When you write portable code, you can easily port back to Helidon from some other environments. And even, if you are like, you want to go to we call it the danger zone. If you want the perfect or massive performance, I would say, there is the reactive way of doing it. And this reactive way is called Helidon SE, will provide you ultimate performance, since it's a pure Java with absolutely no overhead there. And once again, Helidon has perfect for exactly microservices, and has wonderful integrations with other supporting stuff, like we have a DB client, web client, etc. So as you probably saw, with a very easy start, like with using the CLI, or go just to the Archetype, or just a website of MicroProfile Starter, you can easily start microservices and get really a lot of specifications out of the box working for you. So yes, Helidon is basically used for that.
Yeah, but don't sell it short, Dmitry, though, right? I mean, because we just built a simple application that's not necessarily a microservice, but it could be, but it's really just a web app.
No, you see, we are poor. You see, there's a backend, which is exactly microservices. We have this. By the way, microservices in different flavors, I would say. So we got REST, we have gRPC, we have GraphQL. Yep. So with this support, it's exactly like and once again, you see how scalable. Actually, Aleks demonstrated how scalable it is. So we're exactly following the paradigm of microservices. Yeah. So
and the nice thing about bundling Helidon and Coherence together, the microservice truly owns its data, because it's only accessible to it. Nobody else can get to it. So it's embedded kind of in the service itself. So all right, I think that answers that question.
Yeah.
Okay, so I guess the next question is, I mentioned that Coherence creates backups as far as possible from the primary data. What do I mean by that? Coherence has an awareness, to say, of network topology. So we know if two JVMs, two cluster members, are on the same machine or on a different physical machine. We also know if they're on the same rack, or if they're on the same in the same data center. Some of those things require configuration. Like in a physical environment, you have to configure which rack particular member is on and which site it is on to represent data center. But what's nice about running these things in cloud is that it actually becomes much easier. For example, I'm running this cluster in OKE, the large one that I showed. And by simply doing that, we're telling by default, Coherence operator will provision Coherence members across multiple multiple availability domains, and it will know which availability domain each member is in. So what that means is that if we have nodes across different availability domains, we will always create backup copy of any piece of data. So any task that I created, backup gets automatically created in a different availability domain. So we can lose technically a whole availability domain without having any impact on data. I mean, we will not lose any data by losing a data center, basically. So that's what I mean by that. And, obviously in a physical environments, you can go from machine safe to rack safe to site safe mode. In a cloud, it's really easy to go to site safe mode. We just let Coherence operator do what it does out of the box and deploys deploys members across many availability domains automatically.
So it's very smart, huh? Absolutely.
All right. Well, thank you. I think that's all the time we have for questions. Thank you very much for joining.
Yep, I hope you like this combination of wonderful products that we have. Helidon and Coherence are really nicely fit together. So I hope to get your feedback, and thank you for your time. Hope you like it. Bye-bye.